Vendan sir, shall we start this session?
Yes, ma'am.
Yes, yes.
Mm.
Good morning to one and all present here. I welcome all the students. First, I like to thank Vendan sir before starting the session for accepting this session, webinar session on data science, and also I thank Cognizant Technology for accepting the sessions for continuous technical series. This session is about data science. I welcome you one and all. Over
Thanks.
to Vendor.
Thank you. Thank you, ma'am. Good morning to all students of RVS College, and thanks for this opportunity to meet all the young minds. And thank you, Ms. Jayanti, HOD of Computer Science, and other faculty members. So today,
Thank you, sir.
yeah, and today I just wanted to give you a brief introduction about data science and how it is changing the life of the human beings and all over the world. And it would be just an introduction session and not a very deep session, but this I feel that it should give you a good start for your learning and your career opportunities. So just skipping into this modules, just okay. Yes, so agenda of this session will be like we'll talk what is data at the first, and then we will speak about data science, and we'll speak about how the data science is applied in the real world condition, and a little bit about the machine learning, auto ML stuffs, and we'll have some examples run on Excel and Python. And then we will speak about the tools in which we have to expertise ourselves in to learn data science, and never the least what are the career opportunities and jobs, and what kind of salaries are there for data scientist jobs. And at the end, I'll give some introduction where to learn data science and how to master the course and all. And I'll start with the quote which Edward Deming says, like, without data, you are just another man's opinion. It means like, I'll also try to use some of the Tamil words in between if you don't mind. So இவங்க என்ன சொல்ல வராங்கன்னா, லைக் டேட்டா பேஸ் டெசிஷன் எடுக்கிறது மட்டும்தான் கரெக்டாக ரிசல்ட் வரும். பட் அதர் திங்ஸ் லைக் எல்லாருமே அவங்க கருத்தை கொடுக்கலாம். பட் அந்த கருத்து உண்மையாக இருக்கிறதா இல்லையான்னு பார்த்தீங்கன்னா, it should be backed by the data. For example, நீங்கள் வந்துட்டு ஒரு ஜுடிஷியல் சர்வீஸ் போனாலும் பார்த்தீங்கன்னா கடைசியில் ஜட்ஜ் வந்துட்டு எவிடன்ஸ் தான் கேட்பார். எவிடன்ஸ் இஸ் நத்திங் பட் டேட்டா. So that is what he wants to say. And I also strongly believe like whatever decisions we take as a human being is also data driven only. Okay, so just getting into and what is data and how we are seeing data in our daily life. So this is a chart given by a company called Domo, and they say that the data never sleeps. So what happens in every 1 minute of the day? So if you see this Facebook, Instagram, the social media sites, you can see the number of shares happening, the photos being shared. And if you see the new app which came on the pandemic time, the Clubhouse, it has reached a hell lot of users. And then other things like Netflix, Prime, and online, the Google searches, you see like 5 million searches are happening in every 1 minute. So this is the importance of what data is in the 21st century. If you see like when you are in school, like 2016, right, there were only 1.4 billion users out of 7.7 billion humans. Only 1.4 billion users are using internet. But see the growth, how it has been in just 4 years. Like it has grown like more than 4 folds. And they are expecting that by 2030, 90% of population who are above 6 will be using internet. So we are all into this internet world, and internet world is nothing but information and sharing data and sharing information. So just to give an importance what data is. Okay, and this is like the same thing. So 9 out of every 10 persons above 6 will be digitalized by 2030. So we'll speak about what is data. Okay. So data is a new oil. A new oil, why they mention is like oil in a crude format, right? It can't be used for any fuel purpose. But once it is being processed into kerosene or gasoline, petrol, diesel, it can be used as a fuel in many of the locomotives. So that is what the data is also. Data is always on the raw state. It is never it can't be consumed as it is. We have to process it to make it a usable format. Okay. And the data can be either number, text, audio, images, videos, whatever we see around us, like it might be the in the mobile phone or in the internet, whatever we see, it's all data only. It can be, the formats can be either number, text, videos and all. It can be structured, unstructured and semi structured. So what we actually do with the data, and any data, we have to process it to make it as a information. So data can be made as information, knowledge and a wisdom. So that is what raw data is being made into as an information. Once the information we receive, and we can take any decision upon that information. And what all we do with the data is like we extract the data, we collect the data, mine the data, we do a data discovery, profiling, cleansing, analyzing, modeling, validation, transformation, visualization. So these are the stuffs which we do with the data. The most of the thing, the first part will be like data extraction, the second part will be like data processing, and then the data visualization. So last part is a data visualization, so that we have to tell a story based on data. So what actually the data means to us. So finally what we want to have a useful information. Okay. Okay, going back to this slide. So again, like what are structured data and unstructured data? Structured data can be either numbers, addresses, or transaction information, whichever is put on table. Okay. And you would have heard about the term called databases. You have the tabular format, the columns and rows. Anything in a tabular format will be a structured data, and we'll be having the RDBMS or data warehouse to store those data. While as an unstructured format, right, either audio, video, images, text file, even your CCT camera, the surveillance imagery, everything comes under unstructured data, which you can't directly read and collect any information. But how do you store those data is via data like cloud storage, no SQL database. So you'll have to store in these formats. Okay. And these are like structured data, unstructured data. Structured data is like tabular format, and unstructured data is like social media, video feeds and all. And just to start with the session, I just wanted to give a give a explanation. How do you see the data? So everyone are like concerned about what is happening with the fuel prices, right? So as a educated person, we'll have to see a little bit more on why the fuel prices are getting up and low. Okay. So here if you see like here I have the data of July 2021. Here I have the data of May 2021. So if you see, the barrel price has been crude oil price is like 35 rupees per liter, but we are being sold at the rate of nearly 100 rupees per liter. So where do we see how this data is getting increased? So in this table, if you see, right, you don't have any information how this 35 become 99. So you just go for some other information, like to see like how this 34 or 35 becomes just 90, around 90 or 100 rupees. So you see like the freight charges, the logistics and the dealer charges and the excise duty and the value added taxes are put on our fuel to make this price. So how do you visualize it or represent in pictorial format is like if you see this bar, right, you can easily say like the cost of the fuel and the cost of the extra VAT and taxes are like equal actually. So this is the how we have to represent the data. Just an example I just want to give. And again, like in data, what you see, right, if you see like from 2000 to 2021 how the international oil prices trends are, and here you can see the how the Indian oil trends are. Like you can see a hike here, right, and the same hike you can see here also from 2020 to 2021. So based on this prices I can say like, okay, there can be a hike in 2021's Indian oil prices also. So when comparing these two charts, right, one can take a decision like what is going to happen between the international prices and Indian prices. Okay, just to give a visualization of what data is. So how important data is. People who don't know what how to manipulate the data would only see this number and wouldn't see the entire picture what is in behind. But we as a computer science background student, we'll have to go a little bit further to understand what data is. And this is one of the example, like fuel example. But if you come around everything, right, right from your traveling, cooking, or cleaning your house, everywhere some data manipulation is done in a human format. Okay, are you fine with all the, I mean, my space and my uh, vocabulary and all, or should I go slow?
This is fine, sir. Fine, fine.
Yeah, okay, fine. It can also be a two-way. In case anyone has to stop me, you can stop in between. Okay, and
Sure,
see,
sure.
and we'll come into what is data science. We saw what is data, the unstructured, semi-structured data, and what all the data insights can give us. So what is data with data science actually? Okay, and data science is a method providing actionable intelligence from a data using mathematics, statistics, programming, and business expertise. Okay, so when you apply your scientific knowledge into your data, then you can bring out more information in a more logical way, data driven decisions based on your scientific methods you apply. So it is like putting some scientific method and gaining some insights from the data. So first of all, you need a business expertise. What data it is actually. If it is a domain like if for example you are dealing with your college data, the students data, your mark sheets, and the students attendance and all, you'll have to understand how a college works and how the teachers are and how the students come to classes. You have to understand that business to first handle the data. Without understanding the business, we can't understand what data it is. And then you want to know what is mathematics and the probability, statistics, the linear algebra, regression techniques, and programming. And these and all, if you learn, right, but still you can't do everything manually. You need some computer backing up you to all do all these problem solving methods. So you need like programming like Python. And also using these things, can uh, come to a conclusion like that, you can get insights from the data which you deal with. Okay, so first of all you'll have to understand what problem it is, and then the work comes in collecting the data, preparing the data, exploring the data, and building a model upon it, and model deployment. And these terms will be detailedly explained in the coming slides. So exploring the collecting the data, exploring the data, processing is like more than 70% of the stuff is like without doing any model building itself. You'll be just exploring the data 70% of your time, and only 30% of your time uh, you're going to fetch put the data into your models, and you are going to get some insights from it. So major part is like you are going to analyze what data is, process more what data is. And this is a very slow process. You can't like in 10 minutes you can't get an insight from data. You'll be like slowly working with the data until you understand it. And before going deep into data science, I'll just tell what are the roles in data science. Okay, so there is a position called data engineer, and there's a position called data analyst and machine learning engineer, and all put together comes under the term called data scientist. So data engineer, what he does, just like what any engineer does, right, he just understands what the data is, and he collects it, and he builds some building like that. So it is like he collects all the data and he cleans all the data. Cleaning means processing all the data, and his work stops here. And then the data analyst, who has some more business knowledge, what he does, he analyzes the data, he explores the data, he analyzes the business problem, what actually is needed. And once this work is done, and then it goes to the machine learning, and where they build a model and deploy a model. And in some of the small companies, like all the activity will be done by the same engineer, same guy. But in a very big organizations, we'll have a separate team for each of these roles. Okay. And again, the process like data acquisition, preparation, analyzing, modeling, visualization, and maintaining deploy. Anywhere you go, right? Any problem statement you take, this is going to be your mantra. Like you will be starting with collecting the data and cleansing the data, and you'll analyze the data. You'll build a model. You'll get and deploy it and monitor or maintain it. So this is what we'll have to remember. And in which portion you are very strong and you like to expertise yourself, you will be doing that role. Okay. So and coming about this actual data science modeling. Okay. First, what you do, you build a model. Model is a mathematical model in a computer programmed way. Okay. You build a model and then you train your model with your data set. And once you train your model, you test those models, and then while everything is fine, you deploy the model. Deploy the model means you are going to implement the model in this real data, in the future data or in the real data. And then once deployment, you will just monitor or maintain the data. So these are the steps involved in data modeling as a machine learning engineer here. Okay. And just some questions from you actually. I mean, I just want you to think like, what do a human do actually when you all should have ridden a bike or went in a public transport. So whenever you see a signal, right, what you do? Like when you see a red, you stop. When you see a green, you go. For example, I take a scenario like, it is green, and you are like some 20 meters away from the signal. You will just speed up to cross that signal in that green itself. So why do you take the decision? It is based on the visual image what you see, and based on that you take a decision and you go fast. If you see a red, what you will do? You will slow down the vehicle. You won't accelerate it, because anyway you are going to apply a brake on your vehicle. So you will just slow down from the far itself. So that is the decisions what we take in the real time environment. And same goes for cooking also. If you what the ingredients what you add, the smell what you get, the taste what you get. And the same goes for cleaning your house also. You have to go to each corner and clean your room, and you will have to see where the dust is. Visually you process the data in your mind, but this all happens in an automatic way in a brain. But what happens in a computer world? You will have to feed every instruction. For example, if you see like that, one of the autopilot car in Tesla, right? So the camera, what it tells, like it tells like, it visually sees this image, and it represents like this is a car, and it is able to understand this is a person, and these are signboards of each shop and some of the signals. And then this is a signal. It will visually check if it is red or green, and based on that it will take a decision whether to, in which speed it has to accelerate, and in what momentum the car should drive by itself, and what is the steering direction, the direction it should give by itself. So this is all the what we saw earlier, right? The what human do, the same thing if the machine does, it has to process all the information what it sees. Okay. So again, going to one more example, and this is an example in which, this is a global information of how the flood is affected in India. It is like, emergency event management database, which is a global database, and here is the Indian Meteorological Department disaster weather report actually. So here, if you see in this picture, right, the state called Uttar Pradesh is being shown as heavily affected by flood, but in our Indian report we see like, the state Maharashtra is heavily affected by flood. And so based on these decisions, right, and we have one more report like how many death happened in the national wide, and they have the numbers and they have the percentage. And based on this data only, government can take action on which state they have to concentrate more before that monsoon period. For example, if the monsoon is coming on December, they are not going to concentrate more on just Chhattisgarh or Telangana. And this monsoon happens in May month or April month. They have to make some necessary actions before it. So based on these data, right, government can decide which state they have to concentrate, and which necessary preventive actions they can make. So data is going to give an insight to us for what we have to do ahead of time. Okay. So again, speaking about data in real world, right? So everyone would have used your Netflix, Prime, Hotstar. So each, if you like, log in into your friend's mobile, the list of movies in the first wouldn't be the same what is showing for you, because it has been preferenced based on your movie, the movie you watch. The kids, if you see a kids uh, account, right, it will be full of cartoon characters. But if you see a your father's or mother's prime account, it will be like, it will be little like older movies, like 20, 30 years old. But if you see your list, right, it is going to be the newly updated, newly released movies and all. It happens for the same everywhere. And same you can see in the Google search also. Google search won't be the same for everyone. Based on your uh, preferences, it is going to give you the search result. And same happens for the FB, and it is all customized for single user. And if you're more interested in cars, the more car videos will be shown in Instagram. If you are into some modeling business and all, like more models will be shown in your system. So that is how the social media is curated to show you the information. And the Amazon, Flipkart, everywhere. So everywhere the data science is playing a role in understanding like what the user should see at the first. And if you example for Swiggy and Zomato or Ola, Uber, right, the best route is being showed after processing into data science. There is one more term called artificial intelligence, which is a superset of data science, and that is also playing a major role in these industries. Okay, so if you put from Coimbatore to like Chennai, so it is going to show you a route, right? And if there is any blockage, it will show you in a real time. It will divert your route. And if you take a wrong route, it is going to show you new route in your real time. So these things everywhere, what happens in back end is some artificial intelligence is happening with the help of data science. And these are the things which we usually see. But what about other information which are very vital and which we are not uh, we never know what is happening. In bioinformatics, in genetical engineering, we use data science. In urban planning, the government and private companies use data science. The NASA physicists use the data science. The public health, sports, government budgeting, irrigation, flood management, everywhere if you see, right, data use. Even in the election world, even you can see like be it election in US and or Indian assembly election or a state election, everywhere they play with the data to understand what is the issue in that particular region, and what statement should the leader give to get a votes from that particular region. And this is everything. It is a data based, a data driven decision being made actually. Okay, as I tell that AI, the artificial intelligence, is a father of all data related decisions. And here if you see like data, this ML machine learning is here, and the deep learning is here, and the NLP is like whatever we speak, right, it's getting converted into text format, right? Even if I am right, I saw some option here, subtitle setting. Okay, you can see like if you speak to Google Assistant or Alexa, your commands are being converted. Everything is through this NLP, natural language processing. And here deep learning is used for this Tesla cars and visual image. Whenever they want to get insights from visual image, deep learning is used. Okay, and we'll so far we have seen what is data and what is data science. We'll get into a little the dirtier picture, what actually we do with data science. Okay, so whenever we have a data set, right, data set is nothing but we whatever data we get, we convert into a structured format. And then we first understand the business problem what we'll have to do. And we have a model created. We'll have to, based on this business, right, we'll have a model created upon it, and we'll train our machine to understand the data, to process the data. Once we train the machine, right, then we evaluate the solution. Evaluate is like testing the solution. We'll do with the testing data. If it is passed, what we do, we just deploy the model, and we start using the model. In case it fails, we again start with a problem. For example, you have a business like for example, you have a weather data, right? You have to predict today is there a rain going to happen or not. But you have missed to add a parameter called humidity. But you have temperature, wind speed and all you have. Okay, but without humidity, you are just calculating the solution, you get some result, but when you test the data, right, your result goes wrong. then what you do, you just go and analyze what your error is, you add a parameter called humidity, and again you do the same workflow, and then again you test the data, your test result says okay, you are good to go, and then you deploy the model. So this is the flow chart what you do in a data modeling stuff. And this is a training data, and training and testing, you have a set of data like 100% of data. You will split your data into 70-30 or 80-20 into your training or training data and test data. And once this is done right, and you will be deploying it into your real-time data, which is foreseen data. Okay. So again, like in machine learning, how do you differentiate what kind of models you will have to apply? So if you see, like in machine learning, we have two major learning machine making the machine learn. Okay, one is supervised learning and one is unsupervised learning. Supervised learning means we know what machine should actually look upon. We have the labels, we have the column names, what machine should see. In unsupervised learning, we don't have anything. We just put the data and we ask machine to interpret for itself. We don't have any classifications whatsoever. So supervised learning is like it can be either classification method or regression method. We have some slides behind this screen, and we'll see, you'll be understanding a pictorial format what it is. So in supervised learning, what we have labels, and we have input labels, and we have the output data. But in unsupervised learning, we don't have any label, we don't have any column name. You'll have a bunch of data set, and you'll ask the machine to understand by itself. Okay. And in classification, we it is like categorical. Like if you see, like your mails, right, you have your inbox, but some of your mails can be spam and some can be ham is like the important mails, and spam is like unwanted mails and all, or auto generated mail. So to differentiate which is ham, which is spam, we need to understand this classification methodology. And regression is nothing but a straight line, how a straight line or a curved line, how your data pattern works. And clustering is unsupervised method in which the machine itself should understand what naturally occurring pattern it is. Okay. So let me come to this slide later. So this is a regression. So this is a scatter plot, and this is a y-axis, this is a x-axis, and you have data points all over your chart. Okay. And seeing the trend line, you are putting a trend line across it, like how the data is being um, forecasted. For example, if the x-axis, your point is 60, and you can easily say the data should the y-axis point should be lying around these region. It won't be lying here, it won't be lying here. So, and if it is your 100, it's going to lie across, the y-axis points can be lying across this. For example, you have a TV advertisement across sales for if you everyone should be happy being Chennai won last day, right? So in between you might see many advertisements happening. So why are they investing for advertisement? They do a regression methodology first. So they see like whether if they are putting a 50 crores on IPL match advertisement, they want to see how much sales are going to happen. And if it is 80, how much sales are going to happen. So based on this only, they are going to decide whether to increase their amount in your advertisement, or they have to decrease the amount in the advertisement. So this is a very basic data modeling stuff, which is regression. So you, by raising x-axis, what happens to y-axis? But in classification, it's not like that. It is like, for example, these are like good apples, these are like bad apples. So you have to differentiate what are good apples and bad apples. So you drive a line across it, and not a linear line, of course, and you just differentiate into two categories, good and bad. Or it can be like spam or ham, it would rain or not. So such kind of explanation we have for classification methodology. And coming back to this slide, right? So yeah, x-axis is this, and y-axis, for example, the advertisement on IPL match, and the sales of that particular product. Okay. For example, Vivo is sponsoring our IPL match, so they are spending like 50 crores here, and they want to see how their sales in their mobiles are going to happen in this particular IPL time, actually. So they see, like if they spend like 50 crores, your sales are going to be around like 100 crores here, 100 crores, like 1,000 crores or something. If they increase, it is going to increase more. But for example here, right, here they are doing some other techniques, like they are putting advertisements on radio. No one listens nowadays, but it doesn't gives a proper linearity. So sometimes the sales is high and sometimes the sales is low, and you can't understand what is happening. So here if you see, like if I spend 50 crores, right, and on advertisement on radio, it might go up or it might come down. So nothing we can infer from this graph. And here again, like similar thing. And here if you see, right, it is showing like a slightly a negative linear. So if you see this band right here, so it is showing like little bit negative linearity here, coming down actually. But if you see here, right, it is just like a cluster. It doesn't shows anything, you can't infer anything. But here if you see, like it is like strong non-linear. To one point it is increasing, and after reaching this one point it is decreasing. So again, this also is completely non-linear. Only such models we can use for our data, our regression model, to understand how the data is getting, how the x-axis moves across. When the x-axis is moving and increasing, how the y-axis is going to get affected. And you call the x-axis as a independent variable, and y-axis as a dependent variable here. And here we see a negative linearity. Okay. And if you see, like we saw two things, right? One is regression and one is classification. These two are supervised learning. And while if you come for this clustering, right, this is unsupervised learning. So the data doesn't know what it is. This can be apple, this can be orange, this can be grapes. Okay. So but we haven't named it. We don't know what it is. But data, what our computer program will say, it will see for first, it will see for color. If color is red, blue, green, orange, it will check. And if it is size, it will check, apple should be in a oval shape, and orange should be in a round shape, and grape should be in a smaller round shape. And based on those features, right, it will understand what this data is, and it will cluster based according to those features. This is like uh, unsupervised learning, and most of our real-time scenario will come under this unsupervised learning only. Okay. And again, coming to this, right, we saw some graph like this. I can draw a line like this, draw a line like this. But seeing, like we always, while doing data modeling, right, we we have to check whether our data, our this is called a trend line. We have to see whether it is being fitted, underfitted, or overfitted. So in this case, right, we have a good fit. Okay. But in this case we have underfit. It is not following the pattern actually, the trend line. And the trend line is a one which with the help of data algorithms, we manipulate this line actually. But this is underfitted. And if you see these, right, this is overfitted. It is exactly matching these points. And why this is not being this shouldn't be used, because this, in this model, the data points are being memorized by your model, and it is exactly following the pattern. For example, tomorrow if the new data comes here, right, but it will again go down only because it has entirely memorized it. But we should not use this model. We should not use this model. No underfitting and no overfitting. And we have to use some model which tries to fit the pattern at the maximum level. And we have some mathematical reasoning why this trend line should go like this. Okay. And before that, we'll see what is decision tree. Okay. So you saw like three types of fruits and how the clustering is happening based on the features. And I'll give other example here. So any clustering, right, the basic algorithm is a decision tree. Okay. So here, like multiple parameters will happen. So whether rain will happen or not, we have multiple parameters here. Okay. So it is sunny, cloudy, or rainy. If it is cloudy, okay, yes. But if it is sunny, it has to check what is the humidity is, whether it is high or normal. If it is high, there is no rain. And if it is normal, there is rain. And here again, like rain, right, it is windy, strong wind. So based on these calculations, right, the we have to the machine can find out whether it is going to rain today or not. Okay. And another example, like, oh, and what is a random forest classifier means a group of decision tree makes a random forest. So example we saw, like, whether it is orange, cherry, or like any other fruits, if you say, right, it has to check whether what diameter it is, what color it is. So based on these decisions, right, it can conclude what fruit it is. Here we are not giving any fruit's name at the first itself. It should find out by itself. That is called clustering or unsupervised learning. Okay. And again, coming to this linear regression, right, again I'll just try to reiterate, and we have this linear regression, which is a straight line. We have a classification, which is classifying your data points into two classifiers, and here you have a clustering, which is unsupervised learning, in which you don't know, you don't give the labels, but the machine itself takes for itself, finds for itself. Okay. And again, if I'm going little faster, and please stop me, I can go slow. Yeah. And see, and in your graph, right, in your school days, you would have seen this graph, actually, y is equal to mx plus c, and this is what we are going to do. Whatever we read in our school time will go is going to repeat. If parents used to say, right, study properly now itself, it will be helpful, and this particular condition, I really felt that it is helpful now, because this equation is a very normal equation we would have seen in our school life, in our graph, which we used to score 10 on 10 our mathematics. So y is equal to mx plus c. What is m and what is c? The m is a slope and c is that constant variable. Okay, and here this is a linear graph we are going to draw across our data points. For example, these are data points across independent variable x-axis and dependent variable y-axis, and these are the data points. We have to put a trend line across it. Okay, and how do you deduce, like, this is going to be a trend line, and we have some formulas to understand how this trend line should go across this data points. Okay, so here this y-intercept equations here, but in our data science terms, we instead of using m and x, we use beta naught and beta 1, and which this is a slope or intercept, this is, sorry, constant or intercept, and this is our slope coefficient. The slope coefficient gives us a picture whether it is negatively correlated or positively correlated, or the slope, how it is inclined, or negatively inclined or positively inclined. And same here, like, so these are the data points, and you are putting a line through it, and if you put a line through it, right, how much difference this point has to this line is our residual. Okay, so this is called positive residual because the points are above this line, and these are negative residuals because the points are below this line. I think you are able to get something, right? Might be it's a very all of a sudden I'm pitching into this picture. If you want to speak, people can speak in between.
No, sir, we have come across this trend line on
Okay,
from
okay,
Tableau.
okay,
So,
sure,
no
great, great,
problem.
great. Okay, thank you. Yeah, okay, and again, like, so what this trend line says to us. Okay, so, and this being our actual response variable, right, our average point, we have to calculate two things. One is this RSS, this is called RSS, and this is called TSS. Okay, the residual sum of square and the total sum of square. So what we have to calculate is a distance between our trend line and these points. So, and we'll have to square it, and we have average, and these data points should have an average point, right? And from that average point, this is the average line, and from average line, what is the distance between our data point and our average line? We'll have to square it. Why do we square it? Because this can be either negative or positive, but while squaring it, everything becomes positive, right? That's the reason we square everything, and we uh, we check for our residual sum of squares and total sum of square. And this total sum of square is and while doing this calculation, right, 1 minus residuals and by total sum of square, we should get a value closer than 1. If the value is closer to 1, our trend line, right, our this linear line is more um, is more telling about our data, actually. But when the as this value reduces, it means like it is getting underfitted, or it is getting non-fitted lines. So here, if you see this r square, right, this is a equation coming like 1 minus residual by total. Okay, and this is a formula. Again, if I want to repeat you, these are the data points, and this is your average, and this is your trend line. The distance between this you calculate, and the distance between your average and your data point you calculate. You sum this and you sum all the points and you square it, and you square it and sum all the points, and you find a ratio with minusing 1, and you find out this r square. And based on this r square, right, if the r square is like 8.8, it means like your trend line goes across most of the points. But if it is getting lower, right, it goes somewhere, it doesn't follows your pattern. Okay. And we have other points like f statistics and probability statistics and all, and based on these things, right, we saw m is equal to, sorry, y is equal to mx plus c, right? Here it will be giving the coefficient. So this is a constant what we are seeing. If you see, like, this constant is like 6.9 here, and this is a slope we are going to see, it is 0.05. So the equation will be going like y is equal to this. Now y is equal to 0.05x plus 6.9. So this is what we can deduce from this calculation. And we since these data points are less, we can do this. But what if the data points are like in millions? We can't do it. So we will be using some python and some python libraries to do this stuff for us. Okay. And again giving some examples, like what are other supervised examples and unsupervised example. For example, the house pricing. So you have these are the basic um, examples. When you start learning, right, you will be handling such data sets to understand how the data model works. In house pricing, right, you will be having where that the residence, the location, how many number of bedrooms, which floor it is, whether it has a parking, and whether it has attached bathrooms, and what kind of tiles they are using. So those kind of information, if they put in one table or in a columns, right, and they can easily deduce what the house price should be, what is the demand in the market should be. And again, like for example, these are only two variables, one is cat, one is dog. Okay. And what you do, and you just take some features here. You see, like based on its image, and it will put some algorithm, and it is going to calculate whether it's cat or whether it's dog. The same happens for spam or ham. Any two variables you see, right, it is going to happen in supervised learning. And we saw an example for weather condition, how it is going to happen, and also happy customer and unhappy customer. And based on their complaints, any whenever we call our Airtel or any other companies for customer care, right, they are going to have a record how many times we are called. Based on that, they will be having whether we are happy customer or unhappy customer, and they will be giving us offers based on that. Even in Swiggy and all, you would have seen, whenever you complain, even they give some free discounts for you, and the discounts won't be for everyone. For only particular customers they will be giving discounts. So they will be calculating who are the potential customers who should be kept happy. They will be finding out, and they will be giving offers only to them. Okay. So these are all done by supervised learning. For unsupervised learning, right, doing a customer segment. Okay. The customer segments, what it can be, it can be either age group, either gender and location based, urban or rural. So those kind of what work they are doing, either they can be a government employee, a private, a teacher. So those type of customer segments they can do. If you just take your Google and check advertisements, Google ads, right, and if you log in and see the customized the Google would have customized our advertisements based on this customer segments. I might not have a slide, but I will show it at the end if the time permits. And this is a feature selection. Like we saw, like the climatic, whether it is going to rain or not, right, we have to select, we have to check on what are the features we have, like humidity or temperature, wind speed. So these all comes under supervised unsupervised learning. And majorly, which we wouldn't know, like in our COVID pandemic, majorly the data science played a very important role in finding the DNA pattern, because it is getting mutated every then and there. So we need a lot huge data sets to analyze, and based on that they have found out what kind of vaccine is effective on this particular variant. So everywhere this data science had played an important role. Okay. And this is an example on an image on an uh, image of an eye, in which you can see, like using this data science, it has marked this is a normal retina eyes, and but in diabetic retinopathy, right, there might be some issues with the eyes. The nerves would be like damaged or bulged and all. So based on just image recognition software or a model, and it is able to find out what issue might occur in future in your eyes. Okay. And same goes to X-ray also, because I'm just showing the medical terms because so finally, the most effective usage of data science is going to be in healthcare industry, because we don't have enough physicians or radiologists to handle such a large population. So the computer is coming in action to help those physicians and all. So based on this X-ray chart, you can see, right, it is going to take the data points everywhere, and it will find out what issue the lungs have actually, or either he has a TB or any other issues and all. So these are the types of data we have in the image processing. Okay. Okay, I'll just quickly run through an example which I have in Excel. Forecast, sorry. Okay. So in Excel, right, we have some formulas like forecast, ETS and all. And what is actually does here, so how data science can predict our future is like, just like astrologer predicts our future, right? Data can predict our future. So in a airport, based on the previous airport number of passengers, right? In Jan 2017, there were like 26 lakhs of passenger, and slowly going, like February there were 29, February 2020. But if you see on June, July, August, right, might be the school timing, it is like double the numbers. So based on these information, they want to forecast what will happen in the future actually. So if you see, we have data till September 2021, but we don't have data for 2022 and 2023, but they have to find out what is actually going to happen. Okay. So if you go to the forecast chart right here, so if this is a trend line, what is happening in the in the airport
Sir,
industry.
excuse tool you're using it to
Sorry.
forecast? What is the tool you're using to
It is
forecast?
Excel only. It is just a formula here actually. It is
Excel
inbuilt.
only you're using, right?
Yeah, yeah.
Okay.
Fine. So it is going to give a trend line, what it is actually, and this is like high confidence, this is like low confidence, and based on the trend, if you see like March, right, whenever March comes, the data is low. And so the same thing, like March 2022 also, the data is going to be low. But if you see the trend line, right, the trend line is going to ever increasing. So based on this pattern is going to happen everywhere. So based on that, in September 2023, what could be the passengers, number of passengers we can find out. It is not going to be very high at the peak. So based on that, your entire traveling industry will take a decision how many passengers are going to intake. Okay. So, and I have another example here. So here, if you see, right, I'll just I mean, you can all try the same in your home also. So you have here the interest rate and the median home price. So this is a it's a data in US, might be it is in dollars. So how much is the home price and how much the interest rates are? So if the home price is more, the interest rates are less. So they have to calculate based on the interest rate and home price, what the projections will be for the coming up years. Okay. So I just select these columns, I go to data, and I just I go to this insert, and if you see a scatter plot, right, I just put a scatter plot, and this is the same scatter plot which you saw earlier in our slides. So this is the same thing you will be doing in the Python also. So what you do here, you after selecting it, you are going to add, and you are going to add a thread line. You'll have a plus symbol, you will give a thread line. You can see it's a diminishing, it is a negative slope here. Okay. And after doing, if you double click and if you see, right, it is going to give us display the equation on the chart and display the R square value actually. Okay. The thing which we saw on residual, right, the R square value and the y is equal to mx plus c, it is the Excel itself is preparing a model based on it. And now if I have new values, right, if I have values like values like 6, 7, 8 or something. What is this? Okay, I'll have just one value, 6, 8. Okay, 6, 8, right? So I just have to put my formula here, like equal to minus 2 point, sorry, minus 234,409 cos x plus e9 e349. So if I put right, I'm going to get a projection here. For example, if you have this interest rate for the future years, right? Interest rate are like diminishing. Even if you see in India, we earlier had like 10% interest rate and car loans and all. Now it is like 7. They are reducing the interest rate. So as your rates get reduced, right? So what happens to the data set? You can see here. I'm a little bit wrong with the formula. I have to add minus here. Did I add minus? Yeah, so this is the formula actually. You can see, right, that red line, like since this is low, and this red line matches with your x is equal to mx plus c, and this r square is very least, like it is nearing to 0. So this doesn't gives us a very good linear regression. Okay, so this is how you do in the real Python also. Let me just show some Python code for you. Meanwhile, I'll just it is in my different laptop. I will just open it in side by side. Meanwhile, we will be seeing what is the career opportunities in data science. 1 second. Okay, okay. As we saw earlier, right? So we have in data scientists, we have data engineers, data analysts, and data and machine learning engineers. And what are the jobs they do? They do collect, cleaning, and this guy do the exploratory data analysis, and machine learning engineer does the model building, deployment, and all. And where is this? Okay. And the Harvard University, right? They have told that the data science is going to, even in like October 2012, they have told like the data science is going to be the most wanted, sexiest job of 21st century. So other, what are the data science job here? Like you have a data, you saw only three, right? Data engineer, data machine learning engineer, and data analyst. But we have still more other roles also. You can just read it: the data analyst, data engineer, database administrator, machine learning engineer, data scientist, architect, statistician, business analyst, and data analyst and manager. Okay, so this is what which yesterday night I just took an example. If you can read, right, this is, if you even search for Google, right, with this company a data scientist, you will find this job. So what level of package they are ready to pay for just 3 to 5 years experience? If you are like 3 to 5 years experience means in another 5 years, if you say, right, the package they are offering is like 25 lakhs to 35 lakhs per annum. That is a demand what is happening in the data science industry right now. Okay, and the consultancy service, right, might be that is a product based, but consultancy service, you can see like with a 3 to 5 years experience, again, what package they are offering it. And not only that, to just be a little lucrative, you can see that highest package is more than 1 crore per year actually in data science in India itself. So once you master all these algorithms and this programming and all, so the demand for you is going to increase, because you are going to increase the value of their business, either by giving the right data right insights by your data decisions and all. Okay, data driven decisions. So this is what is the salary structure here. So we'll come to how to learn data science. For learning data science, right, you first have to master in maths and statistics, and then you will have to know the programming language like C program, sorry, like Python, R programming and all. And you should, whatever data you are handling, right, you should have a business expertise on it. If you are handling retail data, for example, you have Big Bazaar, and you will have to understand how the retail industry works. And if you are working with healthcare, you have to understand how the patient records, how the bills are charged for each test and all. You have to understand those diseases names and all. And there are many such industries, right? There can be insurance, banking, there can be aviation industry, manufacturing industry. So whatever industry you are expertise it, and only those guys can pitch into the data science. Okay, without knowing the business, if you go, and it's going to be a very gray area for us. Okay, so what makes you learn data science? So if you see, right, first, whatever you see around you, you will have to question it. You will have to download the data. If you want to see the weather report, you have a free source in the internet to download it. If you want the fuel prices, you have a free data set in internet. And if you want to have any clinical record also, like the pandemic situation, the pandemic record, you would have, like, based on that you can have a trend line. If you see a pandemic, right, in the third wave, you can see the curve is like, it's like first third wave and first wave has the same pattern of the maximum and the least. So based on that, they can make a decision, like whether to open schools or whether to open the theaters, because the trend line is low now. Okay, so that kind of information data can give you, but you'll have to first question what is data, and you'll have to download data, investigate it, analyze it by yourself. You can do this normally by Excel itself. And then you have to understand what is the business and programming with the data. Okay, and then you will have to little bit work on the modeling, machine learning, and storytelling is like, once you see the data, right, you'll have to explain what the data tells us. It is like it is a final thing what we are going to tell to the business, or tell to the any organization who wants the insights from the data what you analyzed. So this is a very very important thing. Even ma'am recently told, like just she told Tableau, right? Tableau is mainly a storytelling tool. After doing all the analyzing and representing the data in visual format, right, what story they are going to tell based on the data. The population graph is there is a bubble graph. So that is what a data scientist at the finally is going to do. Okay, and once you do this and all, there's a site called GitHub, and you'll have to put all your works in GitHub so that people can see and comment on your works. And then you have some other blogs, like this you have in kaggle.com, right? If you open an account, you can see all the projects works there. You can, and they have given all the explanation how the project has how they have did their project. And there are some other sites like Analytics Vidya and towards data science. Okay, and so this is a format which you have to start learning data science. First, choose your business domain and which you have to expertise. Download the data and do some modeling on it, and start with Excel and go to Python, and share your work in GitHub, any and ask for help in GitHub. And you have Stack Overflow websites and all. And then you have to learn similar, you have similar modeling already done in Kaggle or Analytics with LI. You'll have those kind of models already built actually. So in learning data science, in programming, you have to excel in Python. You have to read Python libraries. You have to know much about SQL, how to perform these SQL statements on your data. And in your and very large data sets, you have to go for this Apache Spark. Okay, and mathematics, these are the topics you have to just brush. We will all would have read this, but it is, we'll have to see a little bit more in detail. Either the distribution, probability theory, hypothesis nothing but see whether whether for example your ma'am says, like today Mm, okay, today there is exam, and this particular question is going to come. If your ma'am says, first thing in hypothesis theory, what they say, first you will have to do a null hypothesis. Null hypothesis means you will have to say that the question wouldn't come. Okay, and you will have to prove that question won't come. When you fail to prove it, right, that question comes. Might be I'm little confusing, but just Google on this point, like hypothesis theory and null hypothesis theory. You will, whatever you see which people say is true, you will have to prove that false. When you fail to prove it is false, when you fail to reject the null hypothesis, then your model becomes robust. Okay, so that is called hypothesis. Every machine learning problem is on this hypothesis theory only. Okay, and as I told, the business domains can be like retail, insurance, aviation, and all. And in Python libraries, I'll share the slide if through my company. And these are the Python libraries which you have to learn and practice: NumPy, Pandas, this scikit-learn, matplotlib. And these are the visualization libraries: Seaborn and Plotly. Okay, and these are the websites you have to just be checking often. So what are the trends happening, and any examples they are given in data science and those projects and all. And I have given this 5 minutes video, what all I told right now, right? They have just consolidated in some 5 minutes. You can just click on these links, and you can give us a short picture of what the consolidated thing what I told. And we have some courses like Udemy and Coursera, data science. It is a paid course, but unlike in YouTube also, you have an entire course for 10 hours course and all. But these will be a very structured way, and they will help us. They'll give us examples, and they will work along with us. It might cost you a little bit, but I might say like it could be worth. If you are really into data science, you'll have to choose any of these two, or any new. There are some other courses also, you can try this also. These are the basic books you'll have to just brush in as an introduction part. So this won't be like very hi-fi. It will be like very basic things they have given in these books. And tools and application, right? And you'll have to use the id called Jupyter, in which you can run this Python. And Apache Spark you will have to learn for sure, because very large data set you have to put in Apache Spark, because Python won't be able to handle it. Okay, and we have these are all open sources, but if you want to pay and use for organization level, right? We'll be using the SAS, SPSS, and MATLAB and all. These are MATLAB is used for scientific data manipulations and all. Okay, and we have for reporting and the storytelling, business intelligence, we have the Tableau, Business Analytics, Power BI by Microsoft, ClickView, and MicroStrategy. These tools also, any you have to pick one or two tools, and you have to um, master in those things. Okay, and as a data engineer, first we saw a slide, right? In data scientist, the first thing is a data engineer and a data analyst, and then comes the machine learning engineer. So if you want to just check hey, I'm sorry, like my electricity went off. 1 second. Is it audible now? Hello?
Yes, now it's
Yeah, 1 second, 1 second. Where do I go and share my screen? Is my screen shared actually?
yes, sir.
Okay, fine. You are seeing the thank you page right now, right?
Yes, of course.
Yes. Okay. Okay. I was connected to my external monitor and it got off, so let me cancel this. Okay, now you're able to see the slides. Hello?
Just to thank is there.
Okay. Still it is thank you page. Huh? 1 second. 1 second. How to stop this? Okay, I'm no longer presenting. Okay, I think not able to share my screen. My Excel monitor is not working. You can ask any questions if you want. Yeah, are you able to see a screen called Data Engineer and Cloud?
No, just a thank you. That screen is on this.
Okay, stop your screen.
Any doubt?
Entire screen. Okay. Okay, fine. Fine. And so if you want to be a data, I think this screen is visible now.
Yes, yes, it's
Okay.
visible. It's
So
visible.
if you want to learn data engineering, right, in which you will be collecting the data and processing the data, you will have to learn the GCP, which is Google Cloud Platform, and Amazon has some wonderful service, and they are ruling this market in data engineering. Like more than 60% of market share they are owning, and you can learn some services in Amazon. And myself, I'm working with Microsoft Azure technologies. Like we have some tools like Law Storage, Data Factory, Data Bricks, and SQL, Azure SQL and all. So these guys are like coming up nowadays. Like they have like more than 15% of market share. So you have to choose any one of it, and you will have to use these tools, because everything can't be we can't build every tools, right? These guys have their own ML tools and all that, auto ML tools and all. You can just whatever you want to do in code, you can just do and click and drag. You have to choose any one of it, and you'll have to master those. And when you master these things, right, and I'm very pretty sure that your demand in the market will go very high, and you can demand for your salary actually, instead of they giving you a salary. And these are like other machine learning libraries, and this PyTorch is used by Facebook, and they actually developed it, and they are using it for their own machine learning. And the sensor TensorFlow is by Google, and these are Keras, and again another machine learning tool. And you'll have to just pick any one of it, and you have to just excel in those things also. And once you learn everything is right, a very important thing which I see lagging in most of the students is like communication. Like whatever you work, right, you'll have to communicate it. Either even if you see Tableau, right, the last thing will be like the storytelling part. And if you are done with your modeling and all, you'll have to explain what your model does to the business. If you work and if you're not able to explain what it is not going to give any business value. So in a data science, the last thing will be the effective communication. They will be very much ask for the communication only, like not just the communication soft skills, but how you speak on the data, understanding the data and understanding the business, how what exact things you are going to communicate. For example, if you give a wrong information, the decision will be taken wrongly. It will be a huge loss for the company. For you would have seen like big companies like would have went into loss. Even yesterday I was seeing this IPL match. I don't follow cricket, but the last bowler, right, it was people told like it was a wrong bowler, and so the match got and the match was in favor of Chennai. So these are like decisions. They see a real time issue, and they take a decision which bowler to be placed. So these decisions has to be communicated in a proper way. If it is not getting communicated, and then we are going to have a business impact on it. Okay. And you can ask for any questions, ma'am. I'll just try to open this Python. By that time we have some 2-3 minutes time, I guess. Oh, it is 11 now. Okay, we are already 10 minutes delayed. Okay.
Do you have any doubt? On behalf of the students, I just want to ask, what are the tools available in the data science? What we can use it? You told it.
Sorry, ma'am. Once again, I lost your voice.
Tools. What are the tools can we use for data science
Yes,
analysis?
yes, ma'am. Yes, ma'am. Let me. So basically, we have to start with Jupyter Notebook. Actually, this is IDE in which we can use this Python libraries. We had seen this Python libraries, right? This we'll have to learn pandas, NumPy, and scikit-learn and all. And once we learn it with this IDE called Jupyter, we'll be using Python, and we can analyze our data, in which we'll have this some of the keywords. Like you can read the data set, and you can just you can read the data set and you can put a model and you can test and train in Python. And if you have Apache Spark, right, it is also open source, but if you use this Microsoft Databricks, you can use this Apache Spark cluster, in which you can at a time you can just read millions of record or billions of records by Apache. Again, it's open source, but when you go to Microsoft, you'll have to pay for it. And R is specialized for again data modeling, but Python is very widely used. So basically, if you ask me, right, you will have to learn, we'll have to install this Python. If you install this Anaconda, there's a tool called Anaconda. When you install it, we'll have this Jupyter, and we'll have to learn this Python libraries, and we'll have to implement our data model in it. And for in a business level, right, we have the SaaS SPSS, but these are very very expensive, and for learning purpose, we may not be able to use it. And again, even in Tableau, right, we have this data science thing. You have an option called predict, right? You can just predict the trend line in Tableau, and we have in even Power BI we can do the same. Okay, these are the tools. And in Microsoft Azure, if you say, right, you have to start with your Databricks. And Databricks itself, we have let me just try to show this community. So in this Databricks itself, we'll have this workspaces. It'll be like very similar to Notebook only. So we'll be writing our codes here actually, and we'll be running our codes. And we have an option for this. This is a compute, and in which we are going to create our cluster. I mean the computer which is going to work for us. And here we have machine learning. After installing Databricks, right, we have machine learning here, in which we can create a notebook, and we can I'll have to start a cluster. It might take some time. We can put all the, instead of using Jupyter, you can use also this. But Community Cloud Databricks is it has some limitations for free accounts. We can, but I believe like it still has this machine learning stuffs and all in it. Okay, so before that, I'm just joining it from a different one second.
Whether Jupyter is an open source?
Give me 1 second.
Ma'am, is it audible?
Yes, sir. Yes, it's audible. I just asked you whether Jupyter is an open source.
Yes, ma'am. Yes, ma'am.
Okay, fine. We are having Tableau and Pentaho in our curriculum. That's why I asked whether Jupyter.
Okay. I'm just sharing my screen from a different computer. I'll just show what is Jupyter. Okay. So you'll have to install. Is the screen visible? A black color screen.
Yes, of course.
Okay, so just install Anaconda. Is an open source tool actually. If you install once Anaconda, right, it will again take some few minutes to install. So Anaconda Navigator. In Anaconda Navigator, you will have this Jupyter notebook. Once you open this Jupyter notebook, you will be your local host machine will be opening for yourself. For yourself, like if you put localhost this, right. So your machine will open, and you can just create files on this and national division. Okay. So this is how we in Jupyter. This is how we have this notebook. And here we have notebook. We can just the insert cells above, below, and all. We can write our Python code here. For example, whatever we saw, right? We saw NumPy, pandas, and here if you see, right. We would be using a stats model, and we would be using this by what is this? So like the NumPy, pandas, is matplotlib, cblon. So these and all we'll be using it, and we'll be reading a file with this particular keyword. This is my Excel file, and we'll be reading this file. If you want to see the Excel file, right? Okay, this is the Excel file which I gave an example, right? TV was how the sales are going to increase by increasing your TV advertisement. So by increasing your TV advertisement, what happens to the sales? So this is, if you put info, it will give like how many records we have, and if you put describe, it is going to show like what is the minimum standard deviation and what is 25% of the record, 50% of the record, and what is the maximum record. It will give an entire picture of data set. This you can't do in Excel. You need Python to do this.
Okay.
And this is this one the Seaborn actually, and you can just plot your graph with your trend line. So whatever we saw in Excel, we can do in Python in a very easier way actually. So if you see like this TV, right? TV has a very good trend line, but if you see with radio, it doesn't. It has a trend line, but it is not very much fitting all the data points. But if you see newspaper is it is going two ways actually. It can't be taken into consideration itself. And just if you put a pair plot, it's going to show all the data clusters. So if you see the data cluster, it is like very linear. It is like a cluster, and it is like no use to us this newspaper. So this is called again. We have one more thing like heat map. Okay, and it's going to see how it is correlated. Correlations like 0 to 1. Sorry, -1 to 1. So if it is negatively correlated or positively correlated, like TV is very correlated to sales, but newspaper is not correlated with sales. So the numbers will this is sales, right? So newspaper with sales is 0.16 and radio with sales is 0.35 and TV is 0.9. So TV is very much correlated. From this chart itself, we'll understand TV is very much correlated, but just seeing the data, we wouldn't understand, right? But running this one line of command, it'll give us a picture like which particular advertisements is giving us very good sales. Okay, so and once you do you just with your scikit learning, right? We test and train the data. We split it into 70. Maybe this is very new to us, but just I'll give you a little bit of hint so that it will, when you see it in a real in future, you might just recollect some. This is a test and train data, x-axis and y-axis. You just split the data into test and train. You have like 200 records here, and if you put if you put 70% of 200, it should be like 160 records, right? So 160 records will be put on test size, and remaining 60 records will be put on train. Sorry, 140 to 60, I believe. Yeah, the remaining 60 will be putting on test, and after training the data and using the same data, it will test the data, and if the test says okay,
Fine. Sir?
then we
Then, sir?
can use the
Yes.
data. Hello?
Yes, your voice break, that's why.
Oh, okay, fine. So the same thing we saw in Excel, right? Here we're able to see the same thing in linear regression model also. Okay, using Python. Okay, so we can wind it up now, or if you have any questions, I'm happy to answer.
Yes, sir, it's fine. Any doubts, students? Okay, sir. Good afternoon, everyone. I would like to thank our chief guest, Vendan, for enlightening us with his knowledge. Today's webinar was full of knowledge and interesting things. It gave deep insights into the topics and also revealed some interesting facts. Vendan, sir, that is told about data science, analysis with all real-time examples. Really, it was very interesting, sir. He gave about the supervised and unsupervised learning, and how to analysis the data. Really, it was very interesting and it will be useful to our students, sir. Thanks a lot for accepting and giving a session. Once again, I thank you one and all. Thank you, sir.
Thanks, ma'am. Thank you so much.
Thank you, thank you,
Thanks for
thank you.
giving this opportunity. Thank you.
Thanks, thank you. Thank you, students.